radical is that? So we're talking square roots or cube roots or fourth roots or fifth roots or anything like that. Right, but that is a symbol for a radical. Typically you've got numbers inside of it. Right, so works for square roots. If you have a larger one, sometimes you've got a little number out here, right? That's known as the index. So this would be a cube root of something. Right, so that's a cube root. Up top, when there's not one, so when there's not an index up here, you just assume that it's a square root. Right, so the index is technically 2. Right, so these are like the inverse or opposites of exponents.
What'd you call these X and 6?
That's just what goes inside of it, but this little number here is the index. Right, so one of the first things I want to go over is how to simplify radicals. So let's say we have the square root of 32x. Right, so we can't evenly take the square root of 32, right? But we can simplify this, and we can pull some things out of our square root. So we're going to make a factor tree. Right? We love factor trees. So 32, you can, what's any factors of 32? 4 and 8. Right? So factors of 4? 2 and 2. Factors of 8 are 2 and 4. And then 4 we can break down to 2 and 2 again. So, for this, anything that we have 2 of in our final factor, so we have 2 2's here, we have 2 more there. We can pull those out. So, right, so we can pull out 1 2 from this and 1 2 from that. So on the outside we've got a 2 times 2, and then inside we have our 2 left and our x left. So then you can multiply those 2's on the outside, making your final answer 4 times the square root of 2x. All right. How are we feeling? Good. You guys are very... Not really. I mean, we'll add some more numbers and we'll do it with different, with a cube root, fourth root, but I'll show you how to do that here in just a second. You guys are very quiet again today. It's kind of strange. I know. And it's only been 4 days.
I know, but still.
Yeah. All right. So, let's do another one. Oh, yeah, let's do this one. All right, so let's do the cube root of 24x to the 4th. So, first thing we're going to do is we're going to break up our 24. So, what are your favorite factors of 24? 6 and 4. Right, and it doesn't matter which ones you start with, like, because as you break it all down, you're going to get the same numbers anyway. So let's do 6 and 4, which then gives us 3 times 2 and 2 times 2. So since this one is a cube root, we've got to circle stuff in groups of 3. Right, so we can take out a 2 because we've got 3 of them. And so that's going to put a 2 outside, and then we're left with that 3 inside.
Are you still have to do the x before?
Yes, so next we need to deal with our x to the 4th. So, again, you kind of have to take x's out in groups of 3 as well, because if you think about it, x to the 4th is just x times x times x times x, right? So we can take out an x also. I didn't leave enough room. All right, so we can take out an x from our circle. And then that leaves 1 inside. So it's basically the same idea with the exponents.
But how do you know whether on the outside or inside?
So anything that you have groups of 3, right? You can take one of whatever's in that group and it will always go outside. Anything that's left over stays inside.
So if it was to put x to the 3rd, then there wouldn't be an x on the inside?
Right. All right, you guys want to do another one with to the 3rd power like that? Okay. Oh, we should have. I had it, but then I think when I erased
So
it.
it's days
Yeah,
times whatever's on the
yeah, with,
original equation?
yes. Let's see. So let's do a cube root of trying to find a good one here. Let's do 64 x to the 5th. So 64 is 8 and 8. And then we have 2 and 4. So we've got 3 here and 3 there. So that means we have a 2 times 2 on the outside. So we're not going to have any numbers left inside, but we will have some variables left, right? So then with our x to the 5th, oh, I didn't leave space again. All right, so x to the 5th, how many x's will come outside? Or like, will we have any outside?
So we'll have one outside and two inside.
Yeah, 1 outside, 2 inside. So 1 outside, 2 inside. So then 2 times 2 is 4. So final answer is 4x times the cube root of x squared.
Would you keep the 3 in there?
Huh?
Would you keep the 3 in there?
Yeah, you always have to keep that with the radical.
But could we do that to the other?
Alright, so let's do one more like that. Let's do one with just variables. So let's do the fifth root of a to the 10th, b to the 12th. Alright, so those are larger exponents. Another way that I kind of like to deal with those is, so 5 divided by 10 gives us 2, right? So this will tell you how many go outside. If you have a remainder, that's what stays inside. So that means we're going to have an a squared outside, but then no a's inside. But then if we do that with 12, that means we're going to have 2 outside and 2 inside. So like you get b squared and then b squared. I'm going to make my radical a different color just so it stands out a little better. Right, so that way I think it tends to be easier for some people, but so you can, I just do it the other way too so you can see why it works. Alright, so does that make sense, kind of, sort of? For the most part? Yes. All right, so sometimes when we have expressions with radicals that you would need to like add together, you have to have the same radical. So like for example, let's say we have 2 times the square root of 7 minus 5 times the square root of 7. So in this case, you're basically just treating that square root of 7 like it's a variable. So you're just going to really worry about the coefficient. So 2 minus 5 is -3, and then you just keep that square root of 7 with it. Mm-hmm.
So could you do that with different radicals?
Yeah, so the radicals have to match in order to combine things. So if you can simplify it, you need to try and simplify it first before you try to combine. So like, if you have 15 times the square root of 3 and 4 times the square root of 12. Right now, we can't combine it as it is. But if we simplify our square root of 12, then we can hopefully combine it. So 12 becomes 4 times 3, right, which is then 2 times 2. So we can take a 2 out, right? And so since we're taking out that 2, we still have to multiply it by whatever is already in front of that 12. So 4 times 2 would then be 8. And then 3 is left to stay inside. So then now we have 15 square root of 3 plus 8 square root of 3, which we can add together to get what? 23 square root of 3. So if you're just simplifying the square root of 12, technically you would have the 2 outside and then the 3 inside. But in the problem, since there's already a 4 here, you have to take that 2 and multiply it by the 4 to get the 8. All right, and then when we multiply, you can, okay, so to add and subtract, you have to have the same radicals with them. So this one, since they both have that square root of 7, right, you can do 2 minus 5 to get -3, and just keep that square root of 7.
So what's all that's under it?
All right, so this was another example. So for this one, we can't right now add these together because this has a square root of 12 and this has a square root of 3. But if we simplify that square root of 12, so we're going to break that down to 4 times 3, like we were doing before this. And then 4 goes down to 2 times 2. So that would put a 2 on the outside and a 3 on the inside. But since this 4 is already out here, we have to multiply that 4 and that 2 to give us this 8. Yep, and then you got the square root of 3, so then you add your 15 and 8 to get your 23. All right. Any other parts of it you guys need or want me to go back over right now?
Could you do another one before them?
Yeah. Multiply them if they have the same index. So like they would both have to be cube roots or square roots or fourth roots. So when you do something like that, I don't have any good examples of those. So let's say we have the fifth root of 12r squared times the fifth root of 3r. You just multiply inside the same as you would. So 12 times 3 is 36, and then you have r to the third and the fifth root.
And that's because there wasn't anything outside?
Yeah, and if there was stuff outside, you would just multiply the outside stuff and keep it on the outside.
But would you
But they
multiply
don't
the stuff on the inside too?
Yes. No, like, so this has to match. Just the little 5. So if it was like,
Doesn't have to match for those?
the what?
Like the radicals don't have to
They don't have to match when you're multiplying, only when you add and subtract.
Okay.
Kind of like how you can multiply exponents anytime,
Okay.
but you can't add and subtract unless they're the same. So if this was like 10 times the fifth root of 12r squared times 2 times the fifth root of 3r. Then on the outside you would have 10 times 2, which is 20. Then you have your fifth root of 36r to the third. All right, and then finally we have division. So division basically works the same way as it would any other time. So like, let's say we have the sixth root of right, so if you have two of the same radical, you can technically rewrite this as one big sixth root. And then you would just divide inside like you normally would.
Would you also subtract the...
Yeah, and you would still subtract the exponents. So 45 divided by 15 is 3. And then you would have r squared y to the 4. Oh, I forgot one type for multiplying. We're going to have to go back. Real quick. All right, and then the other format you have for multiplying, this
No.
looks kind of like FOIL, and that's basically what you do. Right, so you still technically have to like FOIL these. So 3 times 1 is going to give you 3. And then 3 times the square root of 5 would just be 3 square root of 5. So you basically treat those radicals like variables. And then inside gives you minus 1 square root of 5. And then the square root of 5 times the square root of 5 would be what? Yeah, so square root of 25, which is 5. Then you can do your 3 minus 5 to get negative 2.
Could you go through that again, like
Yes.
super slowly?
Yes. All right, so we're basically foiling. So we're going to do first, so 3 times 1 to get 3. To do the outside, we have 3 times the square root of 5. So it just becomes 3 times the square root of 5. You just kind of like push them together. Right? And then inside gives you a minus 1 square root of 5 because of the negative. And then the last part is square root of 5 times the square root of 5. So since they're both in that square root, you multiply the 5s together to get that 25. And then here, right, so I did 3 square roots of 5 minus 1 square root of 5 is 2. And then the square root of 25 is equal to 5. And then I combine my 3 minus 5 to get my negative 2. Did that help?
And would you not do then 2 plus 2 plus 2?
No, because that 2 goes with that square root of 5.
Okay.
It's like having like negative 2 plus 2x. You can't combine them together. How are we feeling?
There's one that I didn't understand. It was the one before the multiplication, the first one that we did.
All right, so we're going to do our first 2. So 4 times 2 is going to give us 8. Outside, we have 4 times the square root of 2. It's just 4 square root of 2. Inside is 2 square root of 2. And then our last 2 is the square root of 4. So then bring down the 8, and then we can combine this and this together, making that 6 square root of 2. You just add the coefficients. And then the square root of 4 is equal to 2. So then you combine your 8 plus 2 to get 10 plus 6 square root of 2 is your final answer. That help? All right. All right, you guys ready for some homework? All right, we do have a little bit though.